Hello students, in this video we are going to discuss some of the MCQ questions of chemical bonding and molecular structure. We'll move into our first question. Arrange the following in increasing order of dipole moment BF3, H2S, H2O. So you know the dipole moment. If the electronegativity difference is more, polarity is high. So dipole moment also increases. So we'll discuss here in case of BF3 students. So BF3, you know the shape of BF3, that is trigonal planar. So if it is a trigonal planar, what might be the dipole moment? For example, here B, F, this is the second one, this is the third one. So these are the two bond dipoles, and the resultant of these bond dipole I will represent it over here, and this is the third bond dipole. So the resultant of these two dipole is exactly opposite in direction of third dipole, so this will cancel each other. So in this case dipole moment is 0. But in other case, based on the electronegativity, we can differentiate. As the electronegativity increases, polarity is more, therefore dipole moment is also increases. So for this particular question, the correct answer in case of BF3, dipole moment is less, then H2S, then slightly more in this H2O. So the correct option is 1. So we'll move into next question. Which of the following arrangement of molecule is correct on the basis of their dipole moment? First option, NF3 is more than NH3, which is more than BF3. Second option, NF3 is more than BF3, which is more than NH3. Third option, NH3 is more than NF3, which is more than BF3, and none of the above options. We'll discuss in detail. In case of ammonia, I can represent N, hydrogen, second hydrogen, and third hydrogen, and there is a lone pair of electron. Same way in case of NF3, nitrogen, here is a fluorine, second fluorine, third fluorine, and here is the lone pair of electron. Next, BF3, it is a trigonal planar shape like this. So in case of NH3, nitrogen is more electronegative. So I can represent bond dipole towards nitrogen. Here also same direction and here also in the same direction. So the resultant of 3 bond dipole is same in the direction of the lone pair dipole moment. So everything is added up. So here it is highly dipole moment you can observe. But in case of NF3, fluorine is more electronegative. So the dipole moment I can represent like this of 3 dipole moments. 3 bond dipole moments will resultant I can represent like this, and resultant and orbital lone pair dipole moment is in the opposite direction. So here the dipole moment is less comparatively with the NH3. But in case of BF3, dipole moment I can represent like this. So two bond dipole will be, there will be a resultant dipole. Resultant dipole and third bond dipole is in the opposite direction. So it is a 0. In this case it is very less. So the correct option is third one. In case of NH3, it is more, then NF3, then BF3. So the third option is correct one. Which is the correct sequence of decreasing oxygen-oxygen bond length in O2, H2O2 and O3? First option, H2O2 is more than that of O3, which is more than that of O2. Second option, O2 which is more than that of H2O2, that is more than that of O3. Third option, O3 more than that of O2, which is more than that of H2O2. Fourth option, O3 is more than that of H2O2, which is more than that of O2. See, as the bond order increases, bond length decreases. Okay, as bond order increases, okay, bond order increases, bond length decreases. Okay, bond length decreases. So I can say bond order inversely proportional to bond length. Bond order inversely proportional to bond length. So based on this, we can predict that H2O2 is more than that of O3, which is more than that of O2. So the correct option is 1. So we'll move into our next question. Consider species NO3 minus, NO2 plus and NO2 minus. Pick the wrong statement. First option, the hybrid state of nitrogen in all the species is not same. Second option, the shape of both NO2 plus and NO2 minus are bent while NO3 minus is planar. Third option, the hybrid state of nitrogen is in NO3 minus and NO2 minus is the same. Fourth option, the hybrid state of nitrogen in NO2 plus is sp. So we'll discuss in detail. In case of NO3 minus students, okay, in case of NO3 minus, first you need to identify the hybridization, okay. So nitrogen, you know the configuration, that is 1s2, 2s2, 2p3. Atomic number is 7. So how to calculate hybridization? H is equal to half into V plus X minus C plus A. This is the relationship. So what do you mean by V over here? That is number of electrons in the valency shell. Okay, number of electrons in the valency shell. X represents number of monovalent around the central atom, monovalent atoms around the central atom. C represents charge on the cation. Okay, C represents charge on the cation. A represents charge on the anion. Okay, charge on the anion. So in case of NO3 minus, we'll see what is the value of H. So H is equal to half, valence electron is 5 plus 0 minus 0 plus 1, because charge on the anion, that is 1 here, minus 1, so I will write it 1. So that is equal to half into 6, that is equal to 3. So if H value is 3, then it is a sp2 hybridization. Okay, if I will write over here, if H value is 2, then it is sp. If it is 3, then it is sp2. If it is 4, sp3 hybridization. 5 means sp3d hybridization. Likewise, we can write. So it is a sp2 hybridization. Next, we will see in case of NO2 plus. Okay, in case of NO2 plus. So H is equal to half, valence electrons 5, okay, and monovalent surrounding the atoms, that is 0, and minus 1 because here it is a charge, plus 1, so plus 0. Here again that will be equal to 2 only, right? Half into 4, that is equal to 2. So it is a sp hybridization. Okay, sp hybridization. Next we'll see in case of NO2 minus. Okay, NO2 minus. So H is equal to half 5 plus 0. Here it is plus. Okay, plus 0 minus 0 again plus 1. So that is equal to 6, 6 by 2. So it is a sp2 hybridization. So if it is sp2 hybridization, trigonal planar. Okay, both are here, it is a trigonal planar, and here also it is a trigonal planar. If it is sp, then it is a linear in shape. Okay, SP means linear in shape. So we'll see the options once again. The first option, okay, hybrid state of nitrogen in all the species is not seen. Yes, that is right. Correct, no? See here in NO3 minus sp2, NO2 plus sp, NO2 minus trigonal. So different hybrid state you can observe. Second option, the shape of both NO2 plus and NO2 minus. NO2 plus and NO2 minus are bent while NO3 minus is planar. That is a wrong statement. See, you can see the shapes here. That is a trigonal planar, linear, trigonal planar. Different kinds of hybridization you will observe here. Right? Yes, hybridization is different. So the shape is also different. There is no bent shape. But there is a bent shape based on the lone pair of electrons you will observe. The hybrid state of nitrogen in NO3 minus and NO2 minus is the same. See NO3 minus, NO3 minus and NO2 minus, trigonal planar, that is right option. Hybrid state of nitrogen in NO2 plus is sp. See here the second case NO2 plus, it is a sp hybridization. So the second option, the shape of both NO2 plus and NO2 minus are bent while NO3 minus is a planar, it is a wrong statement. Okay, so we'll move into our next question. Among the following, SO2, SF4, ClF3, BrF5 and XeF4, which of the following shape does not describe any of the molecule mentioned above? First one, square pyramidal. Second one, T-shape. Third one, trigonal bipyramidal. Fourth one, seesaw. So we'll discuss in detail. First one we'll see SO2. Students, what is the shape of SO2? SO2. It is a sp2 hybridized. Okay, sp2 hybridized. Here you will see two bond pairs. Okay, two bond pairs and one lone pair. Okay, two bond pair and one lone pair. So the shape is like this. S double bond O, double bond O, and here is a lone pair of electrons. So it is a bent shape. Okay, it is a bent shape. So bent shape, whether it is given, there is no option. Okay, let it be. Next we'll see SF4. So what is the hybridization, students? SF4, that is sp3d hybridization. Okay, sp3d hybridization. Here you can see four bond pairs. Okay, four bond pairs and one lone pair. Okay, one lone pair. Because of that reason, the geometry is seesaw. Okay, geometry is seesaw. Next we'll see ClF3. Okay, ClF3. Here hybridization, that is sp3d hybridization. sp3d hybridization, and there will be three lone pair students. Sorry, three bond pair and two lone pairs. Two lone pairs. So it is a T shape. Okay, it is a T shape like Cl, F over here, one more F, here is one more F, and here is a lone pair of electrons. Next it is BrF5. BrF5 hybridization is sp3d2. Okay, hybridization is sp3d2, and you will observe five bond pairs and one lone pair. One lone pair. So the geometry is square pyramidal. Okay, square pyramidal. Square pyramidal like this. Br. Here it is a, and here it is third. Okay. Next is XeF4. Hybridization. sp3d2 hybridization. Here we'll get four bond pairs and two lone pairs. Two lone pairs. So square planar. Okay, square planar is the geometry. So we'll see our options. Here is a T shape, square pyramidal and square planar. Okay, XEF4 shows square planar. So we'll see. Square pyramidal is there, T-shaped molecule is still there, trigonal bipyramidal is not there, seesaw which is there. So the option is third one, trigonal bipyramidal shape does not describe any of the given molecule in the question. Okay, so we'll move into next question. The correct order of bond angle is, okay, go through the options. NO2 plus is greater than NO2 and which is greater than NO2 minus. Only 3 species are given. So we'll discuss in detail. Okay, so in case of NO2 plus, okay, in case of NO2 plus, hybridization is SP. So linear shape, SP means linear shape, right? SP means linear shape. So what might be the geometry? N double bond O, double bond O, here is a positive sign, right? So it might be 180 degree, 180 degree. But in case of NO2, okay, in case of NO2, first you need to study the hybridization. NO2 hybridization, students. What is the hybridization of NO2? That is a sp2. Okay, sp2 hybridization. sp2 hybridization. Here you will see two bond pairs. Two bond pairs and one lone electron. So nitrogen double bond O and lone electron here. Because of that lone electron which is slightly less than 180 degree, angle is slightly less than 180 degree. Next, NO2 minus, okay, NO2 minus. So in case of NO2 minus, hybridization, already we discussed in the previous question, hybridization is sp2 hybridization, trigonal, right, trigonal planar. So here you can see two bond pairs and one lone pair. Okay, one lone pair. So nitrogen double bond O, including that lone pair of electrons, trigonal planar shape with the lone pair of electrons. So if you observe these structures, what is the correct order of bond angle, students? So the first option is the correct one, NO2 plus, because of the linear shape 180, slightly less than because of the lone pair, it is again reduced. The first option is a correct one. We'll move into next question. Which of the following have been arranged in increasing order of bond as well as bond dissociation energy? Okay, bond dissociation energy. It is purely based on molecular orbital theory, students. So we'll discuss molecular orbital theory of this. Oxygen O2. How to write the electronic configuration of this one? So that is a sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, then we have pi star 2px1, pi star 2py1. So here you can calculate bond order. Bond order is equal to half into number of bonding electrons, bonding molecular orbital electrons minus number of anti-bonding molecular electrons. So here it is 10 minus 6, half into 10 minus 6, that is equal to 2. So bond order is 2. Okay, bond order is 2. Next we'll see O2 minus superoxide. Okay, O2 minus superoxide. One extra electron is there. Here it is O2, that is 16 electrons here. Here it is 17 electron. So that one extra electron will enter here, right? So antibonding orbital. So that is equal to half into bond order 10 minus 7, that is equal to 1.5. Okay, 1.5. Next is O22 minus. O22 minus. Two of the electrons are added. So bond order is equal to half. 10 minus. Here again one more electron will be entered. One more electron. So 10 minus 8, that is equal to 1. Next, in case of O2 plus, out of 16 electrons, one of the electron is removed. So here is no electron in the antibonding molecular orbital. So bond order is equal to half. 10 minus 10 minus what? 5, that is equal to 2.5. Okay, 2.5 is the bond order. So if you observe these options, in case of O2 plus, in case of O2 plus, bond order is very high, that is 2.5, right? Or bond order is 2.5. So highest in this case O2 plus, in which case I think second option is the correct answer. Okay, second option is the correct answer. So we'll move into next question. Select the paramagnetic species out of O2, O2 minus, O2, 2 plus, NO and CO. So we discussed already, okay, here O2, in the previous case we discussed, there is a unpaired electrons, you can see unpaired electrons, because of this reason it is paramagnetic in nature, okay, paramagnetic in nature. Same way, O2 minus, O2 minus, again it is paramagnetic in nature, paramagnetic in nature. O22 plus is diamagnetic in nature. Okay, O22 plus is diamagnetic in nature. NO, again it is paramagnetic, again it is paramagnetic, and CO is diamagnetic. Okay, diamagnetic species. So which is the correct answer? Select the paramagnetic species out of this. So all except CO, no, CO is diamagnetic, and O2 minus is also sorry, O22 plus. These two are diamagnetic. So which option is correct, students? Third option is correct, because CO and O22 plus is diamagnetic. Rest of the species are paramagnetic in nature. So which of the following has a strong bond? Okay, which of the following has a strong bond? So it is again purely based on bond order, as we calculated it in the last question. O2 plus bond order is 2.5. For O2 bond order is 2. O2 minus bond order is 1.5. O22 minus bond order is 1. So what is the relation? Bond order is directly proportional to bond strength. Okay, bond strength. So bond order, in which case it is highest, O2 plus. So the correct option is 1. Okay, correct option is 1. Hybridization of underlined atom is affected when? Hybridization of underlined atom affected when? In the first case, CH3COOH, this carbon is underlined. Second case, second carbon is underlined. Third case, second carbon is underlined. And the D, here it is carbon. Okay, so when it is a decarboxylated, for example, CH3COOH, decarboxylated means what? Carbon dioxide is released. So CH4 plus carbon dioxide. Whether the hybridization of this carbon is changed, here it is sp3 hybridized, here also sp3 hybridized. There is no change. Same way, in the second one, CH3CH2OH is dehydrated. So we'll write the equation CH3CH2OH. When it is dehydrated, you will get CH2 double bond CH2. You studied these reactions. Here it is sp3 and here it is a sp2. So here sp2, there is a change in the hybridization. So the correct option for this particular equation is 2. But in this case, there is no change. Okay, chlorinated, one of the hydrogen, instead of one hydrogen Cl, so hybridization will remains sp3 itself. So here it is sp2 itself, carbon hybridization remains the same, sp2, there is no change in the hybrid state. Next question, among the following species, HXH bond angle follows the order. So you need to know bond angles. So in case of PH3 students, the bond angle, what is the bond angle? That is a 90 degree. In case of NH3, you studied that is 107 degree. Next NH4 plus, that is 109.5 degree, and BF3, that is 120 degree. What is the correct option? PH3 is less, then NH3, NH4 plus, then it is a BF3. So the correct option is first one. Okay, so we'll move into next question. A molecule XY2 contain 2 sigma and 2 pi bonds and one lone pair of electron, the valency shell of X. The surrounding of electron pairs, the arrangement of electron pairs around X is, including lone pair of electrons, we have to predict the geometry. So X, here it is Y, here it is Y, 2 sigma bonds and 2 pi bonds, and there is a lone pair of electrons. So what is the geometry, students? It is a trigonal planar geometry. Okay, trigonal planar is the correct option. So next question, which of the following combination gives bonding molecular orbital? How the bonding molecular orbitals are obtained? If two lobes of the combining atomic orbitals, the same sign overlaps, then the bonding molecular orbitals are obtained. So that is Xi B is equal to Xi A plus Xi B. This is a bonding molecular orbital, and anti-bonding molecular orbital is because of the subtraction. Okay, A minus Xi B. When the two lobes of combining orbitals of opposite sign overlaps, the new molecular orbital obtained is called as antibonding molecular orbital. This is for antibonding. The first one is for bonding molecular orbital. So the correct option for this particular question is the second one. Next question, O22 minus will have bond order equal to dihydrogen and diamagnetic, bond order equal to dihydrogen and paramagnetic, bond order equal to dinitrogen and diamagnetic, bond order higher than dioxygen. As we studied in the previous question, bond order, what is the bond order for O22 minus, students? That is 1. Okay, and it is equal to hydrogen. In case of bond order dihydrogen, that is also 1, and it is diamagnetic. So the correct option is first one. Next question, the correct order of bond angle is, okay, again here you have to bond length, sorry students, the correct order of bond length is, so in case of C22 minus, bond order is 3 and it is diamagnetic. Okay, and it is diamagnetic. In case of C2 minus, bond order is 2.5 and it is paramagnetic. In case of C2, bond order is 2. Okay, bond order is 2 and it is diamagnetic. C2 plus, bond order is 1.5 and it is paramagnetic. Okay, it is a paramagnetic. So what is the correct option? The third one is the correct option. C2 minus, C2, C22 minus, C2 minus, C2, C2 plus, according to bond length, because it is a inversely proportional. Okay, inversely proportional. Okay, yes. Next question, the order of electronegativity of carbon in sp, sp2 and sp3 hybrid state. As you know, as the S character increases, students, okay, as the S character increases, what happens? Electronegativity increases, right? So the first option is the correct one. Sp, here we have 50% of S character, here we have 33.3% of character, here 25. So as the S character increases, electronegativity increases. So the first option is correct. Next, which of the following angle corresponds to maximum dipole moment? So which of the answer is correct one, students? In which case bond angle In which of the bond angle? That is a 90 degree. Why? Smaller the bond angle, greater is the dipole moment. Okay, greater is the dipole moment. So in case of a linear molecules, we observe here it is a linear bond angle is 180 degrees. So it is a 0. Okay, 0. So what happens as the bond angle decreases, dipole moment increases. So correct option is first one. Next question. In OF2, oxygen hybridization. Oxygen hybridization we have to calculate. So we know the formula, that is H is equal to half V plus X minus C plus A. So that is equal to half valence electrons in case of oxygen, that is 6 plus 2 fluorine atoms are there. So plus or minus 0, there is no charge. That is equal to 4 students. So it is sp3 hybridization. So the second option is correct. Okay. Yes. Here we have our last question of today's lecture. That is number of electrons in antibonding molecular orbital of He2. He2 plus, okay, He2 plus is, He2 plus is. Can you calculate, students? First, helium atomic number is 2, so here it is He2 plus, so it will be 3. So sigma 1 is 2, sigma star 1 is 1. So how many electrons are there here? Only one electron is there in the antibonding molecular orbital. So the correct option is third one. Okay, so the only one electron is present in the anti-bonding molecular orbital. So thank you, students.